Hello, math students. Now we're going to take our knowledge of the addition of fractions and we're going to apply it to a real-life example, kind of like you'd find in a recipe. So in this particular recipe, a recipe for cookies includes 3/4 of a cup of flour and 2/3 a cup of sugar. And we're wanting to find out how many cups total are there. We're going to use the UPS check problem-solving strategy. The first step in our problem-solving strategy is understand. What do we know and what do we need to know? And then we also look ahead to the final answer. We want to know what the units are in the final answer. So what do we know? We know we have 3/4 cup of flour. We know we have 2/3 a cup of sugar. And we need to know how many total. So the fact that we need to know the total number of cups lets us know that this is indeed an addition problem. So we're going to solve it with addition. Now the great thing, looking ahead to what will the units in our answer be, it's stated right in the question. How many cups total are there? So our final answer will include the units cups. We now take a look at our plan. How are we going to solve this problem? Well, first, let's create an expression. We've got 3/4 cup of flour and 2/3 a cup of sugar. We take a look at that and plan ahead. In order to add these two fractions, can we do it as written? And we discovered, nope. When you add fractions, you have to add fractions of the same size, the same slices, the same piece. And as we see, the denominators are different. That means they're different sized pieces. So in order to combine these two fractions, we've got to cut them into the same size pieces. In other words, we have to find equivalent fractions. Well, to do that, to find the equivalent fractions, we have to first find a common denominator. And the way we're going to find the least common denominator, which will make our life easier, we're going to find the multiples of each of these numbers, each of these denominators. So we're looking at 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and that's going to look logical. Now let's start with the 4s. We've got 4 times 1 is 4, 4 times 2 is 8, and 4 times 3 is 12. So we have discovered the least common denominator, which is the same as the least common multiple. So now we want to adjust these equivalent fractions, or turn them into equivalent fractions. 3/4, we have to come up with 12 as our denominator. So how do we get there? We're looking at fractions of the same value. So we're really multiplying each fraction by 1. But what does that 1 look like? Well, 4 times 3 is equal to 12. But in order to multiply by 1, you've got to do the same thing in your numerator. So 3/3 is equivalent to 1. So 3 times 3 is 9, and 3 times 4 is 12. And now we do the same thing for 2/3. So now we change our fraction 2/3 into an equivalent fraction with the denominator of 12. So we look at that. 3 times what gives you 12, and that was 4. And so, of course, since we're multiplying by 1, and you often hear whatever you do to the denominator, you do to the numerator, but it's because we're multiplying by 1. 2 times 4 is 8. So now we have equivalent fractions. So now we're in the solve stage. And this is frequently the simplest. You've done all the hard work ahead of time. So now we've got 9/12 plus 8/12 are equivalent fractions, and go ahead and add. When adding fractions or subtracting fractions, once you've established common denominators, you've found the equivalent fraction, you can essentially ignore the denominator. The denominator tells you the size of the piece of the item. The numbers you count up and you combine are the numerator. That tells you how many pieces you have. So we know our denominator will be 12, and we just have to add 9 plus 8, which gives us 17. Now our answer would then become 17/12 cups. Is that the best way to express our answer? Of course not. People would look at you funny if you tried to tell them to do that in a recipe. So what do we have to do? We notice that the denominator is larger than the numerator, or rather, the numerator is larger than the denominator. And that means there is more than 1 in this fraction. So we have to figure out how many wholes we can pull out. We know that 12 pieces represents the whole. So we can pull one of those wholes out of the numerator. So 17 minus 12 gives us 1 whole. We take 12 twelfths out. So that's 12 twelfths. And then what's left over? What is the fraction left over? So 17 minus 12 is 5. 17 and 5/12. So this is what we call our solution. It's not our final answer until we put the units. So 1 and 5/12 of a cup is our final answer. The final part of our problem solving is the part you never should forget. We're checking our answer. And most importantly, we ask ourselves the question, is my answer reasonable? So if we were adding 3/4 a cup and 2/3 a cup, 3/4 of a cup is close to 1. 2/3 of a cup is pretty close to 1 as well. So we're looking for an answer that's about 2 cups. Is that what we got? Well, 9/12 plus 8/12 is equal to 1 and 5/12. It's definitely really close to a cup and a half, so we're in the ballpark. Now we can go through. We used addition to solve this problem, so let's use subtraction to check this problem. So working backwards, we had a final answer of 1 and 5/12 cups. So we go back to our improper fraction, 17/12, subtract our first addend, 17/12 minus 9/12 equals 8/12, and then subtract the next addend. So 8/12 minus 8/12 equals 0, which is the answer we're looking for in a check. So our answer is reasonable, and it is expressed in a logical manner. And we've checked to make sure that our calculations were correct. Good job.